Okay, so we're beginning with DMA50 and we are going to work on the review quiz. We will do it in probably either 2 or 3 parts. So this is the beginning, and I'm just going to go in order of the questions I have here, and I'll show you how to solve each of these using your calculator if you're able to do so. This one wants us to graph the linear equation. We have y equals 1/4 x plus 5. So y equals 1/4 x plus 5. So you're going to go to y1 equals, and you're going to type your equation. Once you type in the equation, we're going to press graph, and then we're going to press zoom and 6 to be sure we're at the standard view. So on y equals, I'm going to do my fraction 1/4. Oh, wait a minute. Where did my 1 go? 1/4. Go beside of it. You have to make sure the cursor's blinking on the outside. The key to the right of the one that says alpha, the very first thing is an X. Always use that key for your X. And then we have plus 5. If you press graph, it'll let you view it. Just in case you have maneuvered around on your calculator some other place, zoom, and number 6 takes you to the standard view to be sure you're right there at the beginning. So as we graph this, we need to have 2 points. The way to get your points, my recommendation is if you will then press the buttons second and table. What I would like for you to do once you do that is to write down, like when you do your test, I always recommend that you write down the ordered pair that you're graphing. I don't want you to redraw the graph, but if you write the points you're graphing, then I'll know if there was an accidental error in the way that you were doing the graph. I personally always start and use x being 0 first. So I'm going to graph 0, 5. That's going to be one of my points, 0, 5. And usually I do not try to pick any points that are fractional form. I like to use ones that have whole numbers. So I'm going to use 4, 6 as my second point. So 0, 5, 4, 6. Coming here to the graph, you need to choose the line tool, which is here. As I move my mouse, look in the top right corner and you can see that the cursor is moving. So I want to go 0, 5 first, and then right to 4 and up to 6. And once you've got those 2 points, you can then save, and well, this one won't let me check because it won't be checked until the very end. But you would save and then check, okay? Use the vertical line test to determine whether the graph is the graph of a function. Now for this one, remember we talked about the vertical line test the other day. With the vertical line test, the graph that we have looks something such as this. What you would do would be to hold your pen or your pencil straight up and down, as if it were a vertical line. If it crosses at one point, we say yes, it's a function. If it crosses at 2 or more points, no, it's not a function. So in this particular one, it would cross at, let's say, 1, 2, 3, 4 places. So this one would be no, it's not a function. So again, if I make the graph longer, and if you had an imaginary line, it will cross at multiple places. So that one is not a function. The circle graph shows how shows music recordings sold by a music store. A music store sells 2,500 recordings a month. How many are country? Okay, so for this one, we have a pie chart. We have 2,500 recordings a month, and we want to know how many are country. So we're going to look back at the graph, and we're going to identify country. So here is the graph. Country is in green. Green is 9%. So 9% are country, but we want to know the number of recordings. So we're going to take the number 9, we're going to divide it by 100, and that's going to give us a decimal of 0.09. We're then going to multiply that by 2,500, and that's going to tell us how many recordings are country. So here, my 9 divided by 100 gives us our 0.09 times 2,500. That will be 225. So 225 recordings are country. Plot the ordered pair 1, -4, and state in which quadrant or on what axis the point lies. So we want to plot 1, -4. We're going to plot 1, -4. Now, just as a reminder, let me remind you, when you are graphing, your x value is first, your y value is second. The x value goes left if it's negative, right if it's positive, and if it's a 0, it stays on the line. The y value either goes up if it's positive, down if it's negative, or if it's 0, it stays on the line. So when you're plotting, you will always start at 0, 0, which is the point of origin. And from there, you're either going to go left or right, and then up or down. So if we're plotting 1, -4, do you see it here? And you can drag it around, okay? So what you do is you click and hold your mouse. We're going to go right to 1, and then we're going to go down 1, 2, 3, 4. Wait a minute, I slipped to 2. There we go. Right 1, well, down to -4. Then it asks us in which quadrant is this. So when we look at quadrants, we name them with 4 values. This one is quadrant 1, where everything is positive. To the left is quadrant 2. Down here is quadrant 3. And here is quadrant 4. So let's look back at our graph. And ours is located in 1, 2, 3, 4. So it would be down here, and it's in Roman numeral quadrant 4. The pictograph shows the number of wildfires in a region between 2000 and 2005. Which year of the years shown had the most wildfires? So for this, we have a pictograph, and we're looking for which had the most wildfires. You want to look at the legend and see how much each wildfire, and they use like a flame of some sort to represent it. And the flame represents 12,000 fires. So you're going to look for, in other words, the longest value of the fires. So let's look back here at the graph. And we're looking at the pictures. This one is here. This one's longer. That's a smidge longer. That appears the longest. And these two come back and they're shorter. So all you have to do is they all have 1, 2, 3, 4. And then as you continue to see which one has the most wildfires, we don't have to give the number for this. We're just going to give the year. So the year for this one is 2003. If we wanted to know how many there were, we would count the number of fires, times it by 12,000 to get the total number of fires. The histogram shows the projected age of householders in the near future. How many householders will be 25 to 34 years old? So here, as we're looking at a histogram of people from age 25 to 34 years old, I want you to, there's going to be a circle. Let me show you here where they are. Do you see there's a magnifying glass to zoom in, to zoom out, and then there's one that's called pop out. I want you to select pop out to see the values more clearly. Otherwise, you have to eyeball it and you're likely to end up missing this particular problem. So let's look here. If I choose the bottom one for pop out, do you see how it makes it much larger? And then when I come down to the bottom, I'm going to look for 25 to 34. That would be this range. I'm going to come up and I have it at this height. I just slide my little mouse over and that would be at 15, 16, 17. So it would be at 17 million householders. So where before we can't see all the increments of lines in between, when you choose pop out, it will make it so those will be visible. Okay, so this answer we have here is going to be 17 million. Write an equation of the line through the point 48 and parallel to 4x minus 3. Write the equation either as x equals, or y equals mx plus b. So that means we're going to leave it in the slope-intercept form of the equation. Okay, so let me jot down what we're doing here. And this relates more to about section 7, where we're talking about parallel, perpendicular lines, and we're looking at how to write equations when you're given a point and a slope, or if you're given 2 points and you calculate the slope. Okay, so let's write down our information. So we have an ordered pair, 4, 8, and what we're going to write is an equation that's parallel to y equals 4x minus 3. Now, let me make note here. I'm going to tell you, do not use this equation. There's only one thing we want from this equation. The only thing that we want, let me make note here, we only want the slope. Why do we only want the slope? Because parallel lines have the same slope. So if we're told that our line is going to go through the point 4, 8 and is parallel to this equation, all we want from the equation is to write down that m equals 4. Okay? Now, ultimately, we want our equation to be in this format, but in order to do that, we're going to have to solve for b. To solve for b, we are going to plug in m, x, y. Okay, so y is an 8, m is a 4, x is a 4, and then plus b. I plugged in 4, the 8, and the 4, these three values. So 8 equals 4 times 4 is 16 plus b. To get b alone, we move our 16 to the other side, and b is equal to -8. So as we write our equation, y equals, we're going to put a number in where the m goes, and we're going to put the number in where the b goes. So the m value is 4, and the b value over here is -8. And that's what they're looking for your final answer, is simply y equals 4x minus 8. We use this slope from that equation. That's all we use. We use the original ordered pair. We use our simplest equation. We have 3 numbers, 1 variable, so we solve for b. And then we come back and we plug in the number m and the number for the b. And you're done. Find the domain and range of the following relation. Also determine whether the relation is a function. Okay, so for this, let's see, it won't let me actually write on this screen. So let me write these ordered pairs down. Okay, we got 1, -1, and -3, 3. So we've got 1, -1, -3, 3. And our other 2 points are 5, 6, and -3, -6. 5, 6, -3, -6. Okay, so when they ask me for the domain, remember we mentioned, are the x values. So the x values are, I'm going to underline the x values in green. So we have a 1, a -3, a 5. Now here's another -3. Do not write it a second time. It would be repeating itself. They will mark it as incorrect if you repeat it. The range are the y values. So my y values are -1, 3, 6, and -6. -1, 3, 6, -6. None of those are repeated, so we just list all of them. When you do your answers for these, do not put any punctuation around them. Notice they have their own bracket that's here. If you put parentheses, it'll be marked wrong. So all you're going to do is to list the values, putting only a comma in between. When it asks you, is this a function? Remember, with a function, every input has only one output, one answer. But if you will notice, for this ordered pair and this ordered pair, both of these have an x of -3. They then have an output of different answers. So since we have these 2 ordered pairs that have one x, but 2 different y solutions, this one, no, it is not considered a function. It has to be one x answer to one y answer. Give the slope of each line, then determine if the 2 lines are parallel, perpendicular, or neither. Okay, so let's write these down. 4x plus 3y equals 9. 4x plus 3y equals 9. And we have -12x plus 16y equals 0. So what we need to do, they want us to do 2 things. They want us to find the slope, and we want to answer, are they parallel, perpendicular, or neither? So to determine the slope, we want them to be in the form y equals mx plus b. So here we have 3y equals, move the 4x over, and we get -4x plus 9. We then have to divide each term by the 3 to get y alone. So y equals -4/3 x. 3 goes into 9 3 times. So the slope of this first equation is -4/3. Only write the number -4/3. Do not include the x. For the second one, the 16y, when I move the -12x over, it becomes +12x. There's no need to bring down a 0. We divide both sides by 16, and y equals 12/16 x. We can reduce that fraction. Both of them are divisible by 4, and that would leave us with 3/4 x. So the slope of this one is 3/4. Now, the rules are for parallel lines, they have the same slope if they're parallel. These two slopes are not the same. To be perpendicular have opposite signs. So that means one is positive, one is negative, and they are reciprocals of each other. So let's check that out. Negative, positive. This is 4/3. This is flipped. It's 3/4. These are reciprocals. One's positive, one's negative. So our answer for this is that yes, they are perpendicular lines. Sketch the graph of the quadratic function and the axis of symmetry. State the vertex and give the equation or the axis of symmetry. For the axis of symmetry. Okay, so let's write down our equation. X minus 7 squared plus 8. X plus 7 squared minus 8. No, plus 8. Hang on, did I write the 7 right? Okay, I had my signs backwards. There we go. Let's get that out of here and fix that. Okay, x minus 7 squared plus 8. So if we are going to graph a parabola, we're first going to go to y1 equals, and we're going to type in our equation. Okay, so let's come here. Y equals, let's clear this out. We're going to do our x minus 7. We're going to square it and then do plus 8. Our next step is we're going to press graph to view it. If we're not at the standard view, we would do zoom 6, but we are at the standard view. To graph a parabola, we need to find the vertex. This vertex is at the bottom. It's called the minimum. So we're going to do second trace, and we're going to choose minimum number 3. So after we type in the equation, we press graph. We did second trace, and for this one, we chose minimum because we're trying to find the vertex. We need to identify what is the vertex of this. So to finish identifying the vertex, it says left bound. Right now, the cursor is at 0.57. So here, way up above is where the vertex is. I'm going to start tapping this right arrow to bring the cursor into view so I can see it on my screen. There we go. You want to be sure when it says left bound that you are left of the vertex. Then you press enter. The word changes to right bound, so I need to move this cursor to the right. Come back and press the right arrow key. Continue to move it past. Press enter. On guess, you just press enter. Now, my vertex, the minimum, 6.9999 repeating, we're going to round that to 7, 8. So our vertex is the ordered pair, 7, 8. When you graph a parabola, you are going to have to graph that point first. Then we're going to go second table to get a second point that we can graph here. Okay, so let's come here to our, okay, so to graph it, we're going to choose our parabola and we're going to find the point 7, 8. So we go right to 7, up to 8. There, I'm on 7, 8. Now notice if you move this, it'll swing around up or down. So I need to find my next point. So if I go second table, my graph goes as large as 20. That's as big as it'll go. So I can't use like the 24, that's too big. I could graph, let's say 417. I could graph any of these other points that are smaller than 20. So I'm going to graph, let's say the 417. So I'm going to go to 4 up to 17. There's my second point. So that is my function. To graph the axis of symmetry, I'm going to choose the line tool. They asked me to make it dashed. I'm going to go back to my vertex 7, 8 and click a point. Now notice I've got a straight line. An axis of symmetry cuts it in half vertically. So make sure your line is vertical and then you can click on any second point. And that gives you your graph of the parabola and of the axis of symmetry. The vertex we identified as 7, 8. And when they ask you to write this equation, the equation is the equation for the axis of symmetry is going to be x equals, and it is the x value of the vertex. So when you write your equation, this one is going to be x equals 7. That's going to be the equation that you write. Okay, and let's do one more. And that'll put us a third of the way through. Whew. Okay, here's a good one. Use a graphing calculator to graph the quadratic function below. Then find the vertex and determine whether the graph opens upward or downward and find any x-intercepts. So this is our equation. Let's write this down. Negative 3x squared minus 12x minus 14. So we have negative 3x squared minus 12x minus 14. F of x equals, make sure I wrote it right. Okay, the first thing they want us to do is to identify a graph. Okay, so let's see, how do we go about graphing this on our calculator? So we're going to go to y equals, we're going to clear and type in negative 3x squared minus 12x minus 14. We're going to press graph to view it. Here we are at our standard view. Notice the parabola, the vertex is here at the top, and the vertex is in quadrant 1, 2, 3. Okay, so let's come see if we can find a graph similar to that. Okay, this graph has the vertex in quadrant 1, so that's not correct. These two graphs, if you notice, C and D both open upward. So we can eliminate both of those because they are in the wrong direction. For this graph, 1, 2, 3, the vertex is here in quadrant 3. So this is going to be our choice for that particular graph. What is the vertex? Okay, so as we're here, so as we chose a graph, our graph looked like that. The vertex, we need to find that ordered pair. So let's come back here to the calculator. We're going to do second trace. It was at the top, so it's the maximum. We're going to choose number 4 for maximum. We need to move the cursor left bound. Right now it's at 0 and way down here at negative 14. So I need to move it to the left, swing on past. It's left bound, press enter. Move it to the right side of the vertex, swing it on past, press enter. On guess, press enter. This vertex, the negative 1.9999, we're going to round to a -2. So -2 is the vertex. -2, -2. The next question asks us, does it open upward or downward? Well, this graph opens going down. So this one opens downward. Then it asks us another question. They say, find any x-intercepts. So when I'm looking for an x-intercept, remember, this is my x-axis here. Does this parabola, this blue parabola, does it ever cross this x-axis? In this case, no, it does not. So this one has no x-intercepts. It does not cross the x-axis. However, when it asks me for the y-intercept, I'm going to do second table, and I'm going to look for when x is 0. I'm just going to do second table. So back on the calculator, second table, where it crosses the y-axis is when x is 0. So it's the ordered pair 0, -14. 0, -14. After you do second table, you look for x being equal to 0, and that's going to give you your solution for y. So at this point, we are about a third of the way through, and I'm going to go ahead and stop here because our video lecture is at about 30 minutes.